Why do we feel warm near a fire? Why do we feel cool when we wash our face? How does fire cook our food? Why does ice make our hands cold? Let's find the answers to all these questions today. Let's understand heat energy. Hot or cold?
Game of heat energy.
Let's begin the game with cold water.
Cold.
2 glasses, 2 colors. We will have a race of colors. Cold water in the first glass. Very hot water in the second.
Hot.
We saw that in the hot water, the color came down and mixed quickly.
The reason for the red color dispersing quickly is that the hot water particles have more energy. They move rapidly in the glass. Compared to them, cold water has less energy. The speed of the particles is slow. In hot water, the water particles and color particles collide rapidly against each other and the color disperses quickly. If we could see, we would see that the water particles in the 2 glasses are in motion. The difference is in their speed. Fast in hot water, slow in cold water. This is a fundamental property of heat energy. Where there is more heat, there is faster motion, more energy. Where there is less heat, there is slower motion, less energy. Let's understand this because this is the science of heat. Everything, be it solid like ice, liquid like tea, or gas like steam, is made from trillions of tiny particles, and these particles are always in motion. In solid objects like this spoon, the particles vibrate in their own place. If heat increases, the vibrations increase. If heat is less, if it gets cold, then vibrations are slower. In liquids like the tea in this cup, the particles are free to move around. If the heat of fluids and gases increases, their particles move at a higher speed. The particles of even the coldest objects are never stationary. This rule should always be remembered. Where there is more speed, there is more heat. Hot. Where there is less speed, there is less heat. Cold. This movement of heat energy can be seen all around us. Like hot tea in the cup, how does it get cold when kept for a while? Particles of the hot tea move at high speed. Now, the heat from the tea heats up the cup, even the air around it. If you put a spoon in it, it becomes hot too, and tea becomes cold. This is because heat energy moves continuously, always from more heat towards less heat. Now, rack your brains.
Hot.
Once again, pour hot water in a glass vessel and add red color to it. Pour cold water in the second vessel without color. What's in this?
Cold.
Cover the vessel with cold water with the plastic lid with a hole and invert it over vessel with the hot water. Now think, why is the hot water flowing into the cold water? That's why when a pan is kept on the fire, a paratha on the pan gets heated up. Clothes are ironed with a hot iron. The coldness of ice does not pass on to our hands. Heat of our hands melts the ice and our hands get cold, ice gets warm. Now you understand why bathing with cold water in summer is so much fun? In the world of science, guessing will not do. Measurement is necessary. We use a thermometer to measure temperature. The unit of measure of temperature is degree Celsius or degree Fahrenheit. You know that water freezes into ice at about 0 degrees Celsius or 32 degrees Fahrenheit and heats up to become steam when the temperature is about 100 degrees Celsius or 212 degrees Fahrenheit. So let's look at the science of heat energy once more. Where there is heat, there is motion. More heat, fast motion. Less heat, less motion. Heat always moves, always from hot to cold.